This is the Honors Geometry Semester Exam Review for Unit 1, Topic 4, which is questions 31 through 41. As I've mentioned in all my other videos, I want to remind you that when you take your final exam, you will get this formula sheet. So even though it's not relevant to this topic in particular, it is something to always remember that you have as a tool. Question 31. Every quadrilateral that is a parallelogram has certain properties. List all these properties. Well, for a parallelogram, we have quite a few. First and foremost, opposite sides are parallel, otherwise it wouldn't be a parallelogram. We also know that opposite sides are congruent. Another property we know is that the diagonals of a parallelogram are going to bisect each other, which means that they're going to split the diagonals in half. We know that opposite angles are congruent. And the last thing that we know, but we didn't talk too much about it in class, is that consecutive angles, so meaning two angles next to each other, are supplementary. So just to be clear, if I had a parallelogram, this angle is going to be supplementary to this angle. All right, so angle 1 and angle 2, measure of angle 1 plus the measure of angle 2 is going to add up to 180 degrees. And then we know that measure of angle 3 is going to be congruent to measure of angle 1, and angle 4 is going to be congruent to angle 2. And because it is a quadrilateral, all four angles will add up to 360 degrees. Question 32 asks, what properties does a rectangle have in addition to those of a parallelogram? So remember that a rectangle and a rhombus and a square all have the properties of a parallelogram, plus more that make it stand out and not be specifically a parallelogram. For a rectangle, we know that all of the angles are going to be right angles. This means that all angles are going to be 90 degrees. And our diagonals, not only do they bisect each other, they're going to be congruent. Finally, for question 33, what properties does a square have in addition to those of a rectangle, which also means in addition to those of a parallelogram? Well, we know that all four sides are congruent. We know that the diagonals, not only do they bisect each other and are they congruent, the diagonals are also going to be perpendicular. And finally, opposite angles, not only are they congruent, but they're going to be bisected, so split evenly, by the diagonals. So opposite angles are bisected by diagonals. And those are the properties of a square. Question 34. If triangle DEF is isosceles, so let's say we have DEF, and it's isosceles, and angle D is congruent to angle E, which sides are going to be congruent? Well, we know that our opposite side matches with that angle. So we know that DF is going to be congruent with EF. 35. In the figure to the right, D is the midpoint of AB, so we know that this is going to be congruent to this side. E is the midpoint of AC, so this is going to be congruent to this part. We know AD is 8, and we know BC is 22. We also know that the ratio of AB to AC is going to equal 2 to 3. So the length of AB compared to the length of AC has a ratio of 2 to 3. So we need to determine the lengths of EC and DE. Well, let's start with the fact that DE, all right, D is the midpoint of AB and E is the midpoint of AC. So DE is the midsegment of triangle ABC. And what's special about a midsegment is we know that, so therefore, the length of DE is half the length of BC. Well, if BC is 22, then DE must be 11. Next, we need to find the length of EC. Well, we know AD is 8, so we know that BD must be 8. All right, and we know that AB over AC equals 2 over 3. Because AD is 8 and BD is 8, AB must be 8 plus 8, which is 16. So what we have is 16 over AC equals 2 over 3. Well, we can cross multiply and do 16 times 3 equals 2 times AC. 16 times 3 is 48 equals 2 AC. Divide both sides by 2 and AC is going to equal 24. So if this whole thing is 24 and AE is congruent to EC, then they must be even at 12 and 12. Therefore, EC must be equal to 12 units. 36. In the figure below, D is the midpoint of AB, so we know that that is congruent to that part, and E is the midpoint of AC, so we know this part is congruent to this. We also know, because DE is then the midsegment, that half of half of BC equals DE. We talked about this with the last question. So they want you to complete the statements using the items in the box on the right. So using items in here, and it says each item may be used more than once or not at all. So AD is congruent to, and we can see that AD is going to be congruent to BD. And because we're talking about a line segment, the line segment is congruent. The measure of the line segment is equal. So AE is going to be congruent to EC. Line segment EC, excuse me. Then we have blank is parallel to blank. Well, that's going to be the midsegment and the third side. So DE is parallel to BC. So DE is parallel to BC. Now we have AD without the line segment above it. So the measure of AD is going to be equal to the measure of BD with no line segment. AE is going to be, the measure of AE is going to be equal to EC. So really these are the same questions as part A and part B, but without the line segment above it. Finally, we have blank equals 2 times blank. While BC is the longer side, and that is 2 times the length of DE, because DE DE up here is the midsegment of BC. So 1, 2 of these is going to give us the length of BC. Then we have the ratio of AB to AD. Well, AB is this whole side, AD is part of the side. So what we have, the ratio of AB to AB to AD is going to be 2 to 1. For every 1 AD, there's going to be 2 needed to make size, or the measure length of AB. In reverse, we have the ratio of AE to AC, and that is going to be 1 to 2. AE is the smaller, 2 of them make AC. Question 37. If 2 parallel lines are cut by a transversal, which angle pairs are congruent? Well, we know that all alternate interior angles will be congruent. All alternate exterior angles will be congruent. All corresponding angles are congruent. And all vertical angles are congruent. Then we're asked which angle pairs are supplementary. Well, same side interior angles are going to be supplementary. Same side exterior angles are going to be supplementary. And then all linear pairs are obviously supplementary. Question 38. Given line M is parallel to line N and angle 1 is congruent to angle 16, we want to prove that P is parallel to Q. So I'm going to write this as a proof. We have our statement, or statements, and reasons. Doesn't really matter whether you pluralize that or not. So the first thing we know is 1, don't forget to number these. M is parallel to N, and my reason for that is given. When I look at that, I can see M is parallel to N. I know that angle 1, for instance, is congruent to angle 4 because of vertical angles, angle 9 because of corresponding angles, angle 12 because of alternate exterior angles. So I have a couple different options with that. But I know angle 1 is congruent to angle 4, angle 1 is congruent to angle 9, angle 1 is congruent to angle 12. Well, I also know that angle 1 is congruent to angle 16. That's a given. And I can see that angle 12 is congruent to angle 16 because we know that they're congruent, but they're also corresponding angles. We also see angle 9 and angle 16 are congruent. Those are alternate exterior angles. So if we can prove that corresponding angles are congruent when two lines are cut by a transversal, then we know that they are parallel. Same thing goes for alternate exterior angles or alternate interior angles. So something like that is going to be the basis for my proof. There's definitely more than one way to do this. But I think the first thing I'm going to do after stating that M and N are parallel is step 2, angle 1 is congruent to angle 12. And the reason for that is the definition of alternate exterior angles. I just decided to say, all right, I know angle 1 is congruent to angle 12. Alternate exterior angles. Now, another important thing is I know angle 1 is congruent to angle 16, and my reason for that is given. Finally, what I notice is if angle 1 is congruent to angle 12 and angle 1 is congruent to angle 16, then angle 12 must be congruent to angle 16. And my reason for that is the substitution property, or you could say the transitive property. Either one works. So if I have now proven that angle 12 is congruent to angle 16, and these are corresponding angles, then what we know is that if two lines are cut by a transversal so that their corresponding angles are congruent, then the lines must be parallel. So we can prove that P is parallel to Q, and my reasoning is, and I'm just going to write that as my reason, if two lines cut by a transversal so that, grammar-wise I should have put, if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. If you want to write something like the converse of the definition of corresponding angles, I'll accept that as well. But remember that you can always write in what you're thinking if you can't remember what the exact reason is. And that is our proof. For 39, we're given that angle A is congruent to angle D and AB is congruent to DE. We want to prove that CE is congruent to CB. Well, I can also see that this angle right here is congruent to this one because they're vertical angles. And now I have angle, angle, side, which will prove that the two triangles are congruent. So I can use CP/CTC to prove that CE is congruent to CB. So to do this, I'm going to do a two-column proof again, statement and my reason. I'll start with, it doesn't really matter, I'll start with AB is congruent to DE. Side AB is congruent to side AB, and my reason for that is given. Next, I know that angle A is congruent to angle D. That also is given. Next, I know that angle ACB, and yes, I need to state this, I can't say angle C. Angle ACB is congruent to angle DCE, and my reason is, you can say vertical angles are congruent, or I'll even just say the definition of vertical angles. So now I've proven that I have a side, an angle, and an angle, side, angle, and an angle that are congruent. So we can say triangle ABC is congruent to triangle DEC, and my reason for that is the angle-angle-side theorem. Since we've proven that the two triangles are congruent, then we can prove that side CE is congruent to side CB. And my reason for that will be CP/CTC. Corresponding parts of congruent triangles are congruent. And that concludes our proof. Question 40. All right, we are given that C is the midpoint of BE, which we know means that BC is going to be congruent to CE. We're also told that AB is congruent to DC. And then finally, we're told that AB is perpendicular to BE and DC is perpendicular to BE, which means that these are both going to be right angles. We can then see that these two triangles are going to be congruent by side, angle, side, and therefore we can use CP/CTC to prove that angle A is congruent to angle D. So again, I'm going to do a two-column proof. I'm going to start with my first given. C is the midpoint of BE. And my reason for that is that it's given. What we know from that is that BC must be congruent to CE. And my reason for that is going to be the definition of a midpoint. Because the midpoint of a line bisects that line into two parts. All right, my next thing I'm going to use is AB is congruent to DC, and that's, again, just a given. And then I have line segment AB is perpendicular to BE, and DC is perpendicular to BE. So this is a given, but we have to work with what that means. So the first thing is, that means that angle ABC and angle DCE are right angles. And we can get that from the fact that the definition of perpendicular lines says so. So the definition of perpendicular lines says that this angle and this angle are both right angles. Well, this also tells us that angle ABC is congruent to angle DCE. And the reason for that is all right angles are congruent. So we have now proven that this side is congruent to this side, this angle is congruent to this angle, and this side is congruent to this side. So we can say that triangle ABC is congruent to triangle DCE. And the reason for that is the side angle side, SAS theorem. So once we have proven that two triangles are congruent, then we can prove that angle A is congruent to angle D, and the reason for that is CPCTC. And that is the rest of our proof. Finally, for 41, below is a figure that will help you prove that the sum of the angles of a triangle is 180 degrees. So this is what we're trying to prove. We've got the triangle that has angles, angle 2, so the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 is 180 degrees. So that's essentially what we're trying to prove. And what we're given is that the two lines are parallel. So we're going to write a proof for this theorem. And remember, we're proving a theorem, so we can't just say, oh, the measures of a triangle are 180 degrees and be done with it, because that is what we're trying to prove. So the first thing we know is that M is parallel to N, and the reason is it's given. The next thing we know, I can look at this and I can see, well, I know that angle 1, 2, and 3, all of these form a straight line, and they, if they form a straight line, they make 180 degrees. I also can see that angle 1 is congruent to angle 4 because they are alternate interior angles, and angle 3 is congruent to angle 5 because they are also alternate interior angles. So I can write that the measure of angle 1 is equal to the measure of angle 4, and the measure of angle 3 is equal to the measure of angle 5. I could also say that angle 1 is congruent to angle 4, angle 3 is congruent to angle 5, but then I would also need to use the definition of congruence because I'd need to talk about the measures of the angles being equal for what we're trying to prove. So I can just go straight to this and say the definition of alternate interior angles. All right, once we've proven that, I also know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And the reason for that is that the sum of, and in this case it's 3, of 3 adjacent angles whose vertices lie on a line have a sum of 180 degrees. So this is just basically saying that the sum of these 3 angles, because it forms a straight line, forms a straight angle, has a sum of 180 degrees. So finally, I can substitute in, if the measure of angle 1 equals the measure of angle 4, I can substitute in the measure of angle 4 for the measure of angle 1. I'm going to keep the measure of angle 2, and the measure of angle 3 I'm going to substitute in for the measure of angle 5, and that equals 180 degrees. So I'm just going to use the substitution property, and I basically have what I wanted to prove. If I want to be really technical, I can put measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 equals 180 degrees, since that's the order I wrote it in originally. And the reason for that is the commutative property of addition. And that's just saying, you know, the measure of angle 2 plus the measure of angle 4 is going to be the same thing as the measure of angle 4 plus the measure of angle 2. I don't think on your exam you're going to have to use that, but just in case you had it, it is there. And this concludes Unit 1, Topic 4 of the Honors Geometry Semester Exam Review.